and the recording has started. So, hello again. Yes, Ritvik is here. Great. At FHERMA, we just have three cool challenges finished. It's like most of you know, Parity, Relu, and CFAR. And today we gathered here to have an open discussions about them. We asked our top scorers and our most active participants to join us to share their experience. I would suggest that you would raise a hand, like Google Meet thing. Let me show you, like this. Whenever you want to ask a question or to reply to some question. And I think we'll start with Gurgen and a couple of words, and with Chaim and Jean-Philippe introducing themselves. Gurgen, mix all yours.
Yeah, hey everyone. Thank you, Alexandra. I would just clarify that today we don't have some formal agenda about what we are going to talk. I mean, the schedule, etc. But mostly we would like to talk about finished challenges. So we finished 3 challenges on FHERMA platform. And the main goal is talk to participants, explain how it was on the FHERMA platform, ask any questions from our side, just live discussion. So I think, yeah, from my side, that just small comments, Alexandra.
Okay. Well, Jean-Philippe, I would give you the word.
Hello, thank you, Alexandra. So I'm Jean-Philippe Bossois, and I'm co-author and main contributor of the LaTeX library. And we'll be here to learn more about our solution. The feedback of the participant for the LaTeX library, and we'll be happy to answer any question about the library.
So if you have any questions about the LaTeX library or how we can use it and what problems do we have on FHERMA with LaTeX, you can ask them to us or to Jean-Philippe. And Chaim, are you ready?
Yes, Alexandra, thank you. So my name is Chaim Shaul. I now work for IBM. So IBM has been pioneering the FHE field for quite a long time. Gentry was working for IBM. One of the first libraries, HELib, was developed by people from IBM. And now IBM is developing a new, it's not new anymore. We are working on that for quite a few years now on a library called HELayers, which let people write code for FHE using packing oblivious coding. That means you code you write your code on tensors, and you can decide on the packing later. So that makes everything more efficient, because choosing the packing does affect the running time. So this is something we are working on. I myself learned about FHE 5 or 6 years ago, I think, and have been developing algorithms for FHE since then. Well, thank you.
Great, thank you. And now I would suggest to any participants who want to introduce themselves or the team, if you are working with a team, to give a couple of words about yourself, where you research or study, what's your main field of interest. You can raise hands. Google Meet should make a nice queue out of it. So let's start with Yanis.
Yeah, hi, I hope you can hear me. My name is Janis Adamek. And actually, I think a team member of mine also joined. I think Dieter is also here, Dieter Teicheb. We are both working for like the Control and Cyber Physical Systems group at Technical University Dortmund. And we have a large field which is called encrypted control. So we are looking at control theory on with homomorphic encryptions. And yeah, we just stumbled over these challenges, and for us is what's really exciting. We sometimes did something in our like working time, but it was more or less a fun experience in our group outside of our working time. So it was yeah, we participated on the Relo challenge, and yeah, we had some details, more or less our expert for mixed integer programs, and we could use that information also in the Relo challenge. And so it was some kind of cool experience for us to interact there.
Okay, Anna.
Yeah, hello everyone. My name is Valentina Kononova. I and my friends participated in the CIFAR challenge. I'm a data scientist originally and do some data science stuff on my daily work. And yeah, first of all, I just wanted to thank you all the participants and everyone who contributed to this challenge and other challenges actually. And we had a lot of fun doing working on this task. And yeah, thanks for distraction us from the routine.
Yeah, I hope that at least for some of you it was fun and engaging, like the challenge, the feeling of it. Okay, Ritwik is next.
Hi, my name is Ritvik. I am a PhD student at Georgia Tech. I work in computer architecture, which a lot of folks from computer architecture are now building accelerators for this. I don't necessarily work in the field of FHE in my day-to-day research, but this was a fun experience to learn about FHE and like try new things. I participated in ReLU and the parity challenge. I didn't even try Cypher. By the time I saw other people's solutions, I was like, yeah, it's gonna be very difficult. So let's not. So yeah, that's my introduction. Thank you.
Okay, next, Osminoshka or Osminoshkas.
So we are two Dmitris. We work in a team with Valentina, so she's Anna Donaris here. We work in a company called Bizon, so we do cybersecurity. I am a data scientist, and Dmitry is a software architect.
That's all.
Okay, you?
Yeah, hi everyone. So my name is Hyungmin and my username is Hita like, on the platform. So I'm a PhD student at the University of Technology Sydney in Australia. And my research is about privacy preserving machine learning. Yeah, that's why I'm very excited to participate in the challenge that is from FHERMA. And yeah, I have started with the FHE for about almost 2 years, I guess. And yeah, I have participated in almost every challenges that is published by FHERMA till now. And luckily, I'm the winner of some of the challenges. Thank you.
Thank you all. It's actually really nice to meet you, to see you in person, or just to hear you, to get to know the people behind the nicknames. Does anybody else wants to introduce themselves, or should we move on?
I think everyone wanted to see Hita. So Hita, nice to see you. And
very great to see you too. Each of
I think we go step by step. Valentina would like to say something.
Yeah, sorry. I just wanted to say that I've been thinking for a long time that Hita is not real. So nice to meet you, Hita.
Nice to meet you. I am very impressed about the performance of you too.
Yeah,
I
I
cannot-
have a great team. Thanks.
You make me like have very headache to beat.
Yeah, you too. You kept pushing us and push our limits a
Yeah,
lot.
I think that is one of the most interesting things about the challenges. We pushing the boundary and try to like surpass each other, and we continuously come up with better and better solution.
It was very great on our side because we observed this competition mostly between Hita and Valentina Kononova, I believe the nickname was from your team. And sometimes the leader changed every 15 or 30 minutes. So we will talk about CFAR a little bit later because it was hacked, but let's do it step by step. But yes, anyway, it was the final result was quite interesting, and this competition approach showed great things. And thank you all for participating. I think we can start with parity challenge. IBM, would you like? Oh, IBM, parity challenge from IBM. Chaim, would you like to share some your thoughts about this challenge, and then we can just go through participants and share some.
Yes. So parity is something that we are interested in. So there are many reasons why. Like for one example, given parity, you can perform bit decomposition. So for example, if you know you have an integer between 0 and 255, that's an 8-bit integer, you can figure out the parity, subtract the parity bit, and then divide by 2 and iteratively get the bit decomposition. So basically, a few years ago, 2 years ago, I think, we had an idea of this bit decomposition only in reverse. We started from the MSB and not the LSB. So we divided the number by 255 and subtracted half, and then changed for the sign, and then removed the MSB and iteratively got the bit decomposition. That was slower than what you proposed. It has some advantages and some disadvantages, though. So it was interesting for us to know if there is another way to tackle this problem, like from the other side, not starting from the MSB, but starting from the LSB, and then figuring how fast it would be, how easy it would be, how easy it would be scaled to more than just 8 bits. So yeah, so that was an interesting challenge, and it was a very interesting. It was very interesting to see the competition between you and Valentina, like how they pushed each other and reduced the times by milliseconds at each time. And yeah, and so after we saw the used solution, we also were very interested in seeing the code and watching and learning what you did there. It was very impressive, very nice.
Thank you. I just would like to add some information about parity challenge. So the winner in OpenFHE library is Hita. In Latigo library, so the best solution provided by Jean-Philippe. But as far as Jean-Philippe in our committee, we decided that we can't considered like the winner solution just to make it more transparent. But anyway, Hita, maybe could you provide some your thoughts about your solution, how you came with this solution? Because initially we started the first solution passed on the platform took around 40 seconds if we talk about OpenFHE library. And finally, we have the best result with around 2 seconds for OpenFHE and 1.5 for Latigo library. So Hita, would you like to provide some thoughts on your solution?
Yeah, okay. So I think a common approach of us for that challenge is to approximate the psi function, right? I mean the trigonometric psi function. So yeah, at first, in my initial solution, I was using just the plain Chebyshev approximation of that function. So I think the polynomial degree I used in my initial submission was about 200. I don't quite remember, but that's why it's very slow. So recently I tried to, then I gradually try to reduce the runtime by using the double angle formula. So that is my idea, but I found it very similar. It shares a very similar idea of how we evaluate the psi function in the OpenFHE library. So that function is used in the bootstrapping operation. So when we try to remove the noise, we have to evaluate that function. And in the libraries, they also use the double angle formula. But here I just a bit different between my solution and the solution in the OpenFHE library. I try to approximate the cosine function instead of the sine. But in the libraries, they evaluate the sine. Then I need to use a shift of the input to make the output. The final output is the psi function. Yeah, that is the overview of my solution. So in my final solution, I think the computation depth is about, I didn't remember, but I think the computation depth is 11. Yeah, 11. And I used a polynomial of degree 16, no, degree 8 to first approximate the psi function. The psi function of I think it is of psi function of x, and then I try to apply the double angle formula to gradually compute the psi function of maybe 16x. I don't remember the details, but it's the general approach, yeah, that I can share.
Thank you. That's great.
Yeah, I'm also very curious about the solution from Jean-Philippe. I think that is quite amazing, and I'm still curious about that. Also, yeah, I can't wait to see the approach that he did.
Yeah, Jean-Philippe, please.
Yeah, so I had the same approach. I'm very familiar with the bootstrapping for CKKS and computing the parity bits. I say, yeah, we can use a periodic function, and then I thought about the cost, and you can use a scale cosine function with a shift also to get the bits. So actually, we have a very similar approach. But I think I use a polynomial of slightly higher degree with less iteration of the double long formula. But I also added some concurrency in Latigo, and this is why it's slightly faster. There are some steps I use Go routines that can be parallelized.
I see.
But the approach is because I reviewed some of the solution, and the approach, the base idea of the approach is identical, is to use a trigonometric function to approximate. And we have very similar polynomials. And I have one question for you is, what do you use to approximate the cosine?
So I use a package in MATLAB. It's the shape fund. So there they provide the tool to approximate the function to find the minimax polynomial approximation, and also the multi-interval minimax approximation as well. So you can check the shape fund package in MATLAB.
You use the mid. Okay, yeah, thanks.
Yeah, thank you.
Yeah, so
Ritik?
I'm
Yeah.
wondering if Valentina also took the same approach.
Valentina didn't participate in parity challenge. Ritik participated in a parity challenge. So Ritik, would you like to share some thoughts, your approach, and yeah.
Yeah, sure. My approach was also similar. You can approximate parity by, I think, cos square x by 2 or something like that, shifted cos square x by 2, and then you use double angle formula, and you, at the end of the day, you calculate cos x by 256 or something. And I did that with, I think, a 7-degree polynomial. So my solution took 12 levels. I added a bit of concurrency in the open FHE solution. And yeah, when I look at Hita's solutions in Go, I was like, yeah, I'll leave it. I'll not try to figure out how to use Go routines in this. So I think, yeah, the key difference was he mentioned that he used 11 levels, and I think that's where you probably get another 0.5 seconds of bump. I'm not sure how he did that, but yeah. So maybe he approximated, I think, cos 128 with a 16-degree polynomial rather than going one level deeper, which I think I did. So yeah, so that was my solution.
Thank you. Great. Jean-Philippe, please.
Yeah, one more thing for Hita. While reviewing your solution, I saw that you coded everything by hand for the polynomial evaluation. And it allowed me to find some issue in Latigo with the automatic polynomial evaluator that was not doing what it was supposed to do. And thanks to that, I was able to fix it. And now it gives the expected result that you would have if you had done it perfectly by hand like you did. Instead of, yeah. It was, so thank you, in a way. Help me to fix Latigo.
Yeah, great. So do we have any topics around parity challenge, or we can go to the next challenge?
Just one my opinion. I think that is very useful as well. I think we can like improve the performance of the library inside the library as well if we apply the way we solve the parity challenge. I try to replace the side evaluation in OpenFHE by my solution, and it shows that it can introduce some improvement there in terms of computation time. So if we, I think it's possible, but we have to try. Yeah. Yes, my thought.
Thank you. I think I can add some small comments around it. We are going to add new types of challenges or extend possibilities for current challenges where it will be possible to use some tuned version of library. So we're currently working on it, and it will allows everyone just to make some tunes inside library, and we will be able to evaluate your solution with, let's say, your version of library, which may add these advantages for library. We are currently working on how to make it more transparent and fair, but I believe that next challenges will be with this feature. Let's go to ReLU challenge if you don't mind. So in ReLU challenge in OpenFHE library, it was black box challenges where we evaluated just accuracy. And the winner in OpenFHE library is Yanis, your team. And please, would you like to share your thoughts and present your solution?
Yeah, actually, thank you very much for this opportunity. Actually, there were two test cases. So the first test case was with a relatively large multiplicative like depth, and yeah, we thought directly that ReLU we had to approximate with a polynomial, and actually for this large for this large multiplicated depth, you could just use like Chebyshev regression that is already implemented in OpenFHE. So to 100% accuracy. So that was, I think many people had like 100% accuracy there, and because there was no time difference, it's like most of all the second part, which was really interesting. Because yeah, from our experience, actually, if you do Chebyshev polynomials, you're getting like 60 to 70%, something like that, with this multiplicative depth of 4. So what we did is actually we like try to fit a polynomial which does exactly what the challenge is trying to do. It tries to stay in this like epsilon environment of 1 to the power of -3. I think was like the limit in which it should stay. And yeah, we solved a mixed integer program for that to get like the best polynomial, which in this bound of -1 to 1 stays as long as possible in this surrounding, and therefore gets the highest accuracy. So we directly used the accuracy, which was later on also the performance metric, actually as the optimization value. Of course, it's really tricky to evaluate that. And yeah, the other trick that we had was normally you are evaluating until if you have multiplicative depth, so it's already in the literature that you can evaluate to polynomial degree of 15. But as we were already on mixed integer, we actually said that we can use the last degree to be an integer. And therefore we could, instead of using another multiplication to get a coefficient multiplication, we could use a sum actually of the different of the highest of this like of the 16th order monomial, and then we could actually sum that up. And because we already had a mixed integer formulation, it was easy for us to just say, okay, the largest, it has to be integer, and then we could use, in this case, it was subtraction because this integer coefficient was negative. But yeah, this increased our performance by a bit, and that's, to our knowledge, was one of the possibilities where we could, get to that value.
That's great. Thank you. In OpenFHE, Ritvik, you also provide good solution. Would you like to add something about it?
Yeah, so I am not from that. I do systems for my day-to-day work, so all I knew was linear regression. So what I did was, let's say you modify your input from just x, which is the given value, to x square, x cube, up to x to the power 16. I used the integer approach for the 16-degree polynomial that Yanis used, and essentially like trained the coefficient of a linear regression model. The two or three tricks that I used was the 16-degree polynomial could be an integer, you can ignore certain values close to 0, let's say minus 0.1 to 0.1, because they're hard to approximate. So if you just ignore them while training your linear regression model, your performance is a lot better. And the third thing that I did was, so you can assign weights to individual data point. So because you had this error limit of 0.001, I could reduce the weights of the values whose error was really small and give it to values whose errors were a bit higher, so that overall I get a better performance. So yeah, my approach was, I don't know, something similar to what Yanis did, but yeah, linear regression is the max I know. So yeah, that was my solution. Thanks.
Yeah, thank you. So in Latigo library, the best solution provided by Jean-Philippe, and the winner solution from HITA is based on the accuracy quite similar. So maybe Jean-Philippe, maybe would you like to try to explain your solution, and then HITA will explain his approach?
So I use the multi-interval minimax approximation premise algorithm from Latigo. And since the value that are close to 0 will stay close to 0, for this polynomial, I fine-tune the interval using binary search to maximize the number of value that had an error that was below the tolerated error. And yeah, so it was an approximation over 2 discrete intervals that minimize the error. So from -1 to some interval and symmetric to plus the interval to 1. Yeah, that's it.
Thank you.
Yeah, I think I did a quite similar way at Jean-Philippe. I also tried the multi-interval minimax approximation, but instead of using your Latigo library, I use a function in MATLAB to find the approximation polynomial of degree 16. And to evaluate the polynomial of degree up to 16, I first divide the leading coefficient of the polynomial to make the leading coefficient become 1. Then we can evaluate it using 4 depth of multiplication. And to get it to the right scale, I just do the rescale operation in the final step to convert it to the right scale. Yeah, that's my approach. At first, I tried the FHERMA approximation in Latigo, but it seemed to be some error. I think it's because of the precision matter, I think. So I have to switch to use MATLAB. Yeah.
You can give there is a parameter to set the precision of the arbitrary arithmetic.
I tried some, but I think there's some error about the number of the roots. It cannot find enough roots.
Maybe there is some fine tuning to do on the
so we
steps
have to,
for the interval. Yeah, this issue can happen.
Yeah. So I try to move to MATLAB instead.
Good. And almost all of participants tried to provide solution with OpenFHE and Latigo library too. So maybe if you want, can share your experience about it. I can explain why we started with OpenFHE and Latigo library, because both of them provide totally open source without any restrictions. So this is why we started with OpenFHE Latigo. And yeah, if you want to just share some thoughts about it, also please feel free to share. Yeah.
Yeah, so after trying every approach and not getting closer to the top 3 solutions, I did this analysis on generating inputs from all random seeds from 1 to 1,000 and just testing it out, just brute forcing. And I actually saw quite a bit of variance. So I saw solutions that were 20 or 30 points more than what the best solution was, and sometimes even 200 points below what the best solution was. So I think one thing that I thought that there was slight bit of overfitting, if I may say so, based on what the random seed was. I might be wrong, but yeah, that's my thought.
Yeah, great. Thank you. So any question about ReLU challenge, or we can go to the CIFAR challenge? Yeah, Yanis, please.
Yeah, I have one question to like Janice team, if I spell it correct. So I heard that you use the integer approximation to find the polynomial for the ReLU challenge, isn't it? So
Yes.
I'm
So
not
do you mean
familiar
the leading integer coefficient or the mixed integer program that we are using?
So just the only leading coefficient is integer, right? And other can be like a real number.
Exactly. Yeah.
Okay, got it. And what tool did you use to find that solution?
We actually, because we already had an inherent mixed integer problem. That's just the way we created our polynomial. It was Mosaic. It's the solver for solving mixed integer problems. I don't know whether you are aware of the tool. Other tools to solve mixed integer problems are Ruby. It's also like more or less accessible if you need an academic license, but you can just click and you directly get that. So in case you will ever need that, those are really good solvers from my experience, but the expert on that would be Dieter in my team. So I'm not.
And how many data points did you use to solve the problem?
I think the underlying data points where we looked whether they are in the epsilon or not, I think it's like 10,000 or something like that.
Yeah, it was about 10,000 in the interval from -1 to 1. And then, yeah, like Jans already said, we designed our cost function in a way that we use binary variables that are 1 if the value is inside this epsilon tube. So they are 0 if they are inside the epsilon tube and 1 if they are outside. And then our cost function was directly the summation over all the binary variables. So we directly minimized the number of outliers from the epsilon tube.
I see. And how long did it take you to get the final solution?
So it was quite fast. I think to solve this optimization problem took about 10 seconds, something like that. But it is also because I observed that the outliers are mainly in a small area around 0. So I included further constraints that lead to the fact that if we have points that are far away from 0, they are forced to be inside the epsilon tube. So they are directly set to 0. So with this little trick, I could reduce the number of binary variables in the optimization problem, which makes it much faster to solve. So if all the binary variables would be free or could be chosen freely between 0 and 1, then it probably would take hours to solve the problem.
Yeah, I see. I think it would be great if we could get some visualization of the approximation and compare between the solutions. It's better to understand.
Yeah, we are preparing the post at the moment for the website. I think it will be online soon.
Thank you.
Yes, I believe for all of the new components, for all the winning solutions, we're going to have some accompanying materials. I'll also try to see about the scheme if we can make up something. I see we have Professor Moritz joined us. Maybe you would like to tell something about your team, how you prepare them how they achieved success and
Well,
took the first place?
yeah, well, thanks a lot. Actually, I'm in a train, so the connection is very, very bad. So probably it doesn't make too much sense because there might be a huge delay. But yeah, super cool. We are happy to have won the challenge, and yeah, looking forward to take maybe part in a few more.
Okay, great. We'll be looking forward to your participation. If there are any other questions about ReLU or working with OpenFHE and Latigo libraries on ReLU or about black boxes, yes, Yanis, you go first.
Just one short question. What was the reason to choose accuracy as like the performance metric? Because yeah, like there could be other performance metrics like the maximum deviance to the real ReLU function or something like that. Why do you choose accuracy on this path?
Do you mean why we choose accuracy as the main metric, right?
Yeah, exactly. So yeah.
Because in black box challenges, it's quite difficult without source code to measure performance. So we can just do it based on some metrics like, let's say, levels, but it's not necessarily right way. And accuracy is the most transparent thing we can measure. And moreover, black box challenges mostly suitable for tasks where we have some solutions. So let's say we know how to achieve 90% of accuracy by Chebyshev approximation, etc. But we want to achieve better accuracy, or we don't know solution. And at this stage, it's not important the performance. So the question is it possible to do it or not? Because in most cases, when we talk about performance, it's a little bit tricky thing, because maybe you will develop really good solution from theoretical side, but without some knowledge in developing in library, etc., you will not be able to provide the best from performance side solution. And
okay, thank you very much.
Yeah. But mostly we try to push black box challenges, as I mentioned, for the task where we just, it's not, at least it's not the main part performance. We just need to find the better solution, and then we can add as a white box challenges to improve performance. So any other question about ReLU or black box, or we can go to the main hot challenge, I would say, CFAR. Okay, let's move to CFAR. It was, for me, it was the most interesting challenge because it was the most active part. As I mentioned, the lizard changed few times per each hour at the end, at the last days of the challenge. And I suggest to start, Valentina, maybe you could start and explain your thoughts, your experience. We didn't finally announce the winners of this challenge. We will do it by Tuesday. We would like to choose not only the first winner, but we would like also to provide some bonuses for the second place. And currently we are under just checking solution to exclude any tricks, etc. Some info about challenges. The goal was to develop the model that will be able to classify images from CFAR dataset, from all CFAR dataset, including test dataset. It should be, we expected that it will be quite simple because we have all images as public, but finally it was more interesting. So Valentina, would you like to start?
Yeah, of course. First of all, I want to say that why we got interested in CIFAR challenge, first of all, because of the ML part, because it was our main domain. And when it comes to image classifications, like convolutional neural networks, immediately come to mind. And the questions that we had, like how we can make it work with encrypted data, how it can affect on basic operations like addition, multiplication, and what about activation function? A lot of like these kinds of questions, and moreover, we knew nothing actually about homomorphic encryption before this challenge, but the Open FHERMA repository helped us a lot. We quickly found how we can implement additions, multiplication, and rotation operations. And we studied a lot of articles about convolutional neural networks in the context of the encrypted data. We found some good ones that succeeded in training, even in training, in classification, and they used like different ReLU approximations. But yeah, later we realized that it would be a very slow solution, and as you can remember, that our first solution was quite slow compared to the latest one. And also, actually, we realized that the model itself is not the main part of the challenge, and this challenge doesn't require a model, necessarily require a model with a good generalization ability. And the main objective is make it work on encrypted input. And specifically from the CIFAR dataset. Yeah, we tried a lot of things. We tried to parallelize the calculations, but we had some difficulties because usually it can be done relatively easy, but with encrypted data, it was quite hard to move it between the Python processes. And we decided to keep to stay focused on the algorithm itself, on the model. And yeah, we tried to win these milliseconds here and there. We spent a lot of time training the data neural network. Yeah, and I think Dmitry is the best person who can tell more details about this process. So I'll pass the mic to Dmitry.
Thank you. So we, as Valentina said, so we decided not to implement CNN, so convolutional neural networks. We decided to implement fully connected neural network just to remember the data. So for every encrypted vector, we produce a new encrypted vector with this CIFAR classification result. We figured out that multiplication depth is very expensive. So for each multiplication level, we increased the price for 30%, so around 30%. So we started with a very high multiplication depth level, and then at the end we could solve it with only 3 levels. So we also found that reducing the dimensionality of the input vector is not as efficient as reducing the number of neurons on the hidden layer. So we reduced the amount, so the number of hidden neurons from, I don't know, 64 to 16 at the end to get 100% accuracy on the whole data set. And we could also obtain 14 neurons to get 85% accuracy. So locally, so we trained it with PyTorch on the consumer grade GPU. So it took 2 days to train 100% accuracy, and another 2 days to get another 85% accuracy. So yeah, that was quite challenging, because also when we want to train a neural network, maybe 10% of neural networks could get 100% accuracy, but it doesn't work all the times because they get to a local minima. And to solve it, so we made some hacks or tricks to enforce the neural network to get to the right weights. So we trained with, so at the end we had a quadratic activation function, but to train the neural network to get to best weights, we used a cubic activation function. Then we trained again with quadratic activation function. And at the end, to reduce, so actually it was quite easy for 18 neurons, but to reduce the number of neurons, even with cubic activation function, it was too difficult. So I decided to remove 2 neurons, like a surgeon. And so we could also fine-tune the neural network with 16, then with 14 neurons. Yeah, we utilized a second degree optimizer, so LGPFS, LBFGS, because Adam or stochastic gradient performed, so in my case, poorly. Yeah, so then after we had this, we moved to Go library. So this is here Осьминожка comes in.
We began our challenge by initially creating a prototype in Python using the OpenPHE library. Next, we started development a solution in Go using Latigo library, but we immediately encountered several challenges. At first, the initial version of template repository contained not functional code, forcing us to borrow code from other projects. Next, there were no test cases in Docker. Backend support for rotation or Galois keys was missing. And next, a bug in the Latigo library, it's impossible to correctly deserialize output data. And the same test cases yielded different timing results. We had to make multiple submissions. The time difference was around 50–60%. Despite these issues, we overcame all obstacles, and you refined the backend verification on your end. We organize the project structure to allow separate testing of each model generation and function, measure performance, and compare results. For this purpose, we wrote unit integration and performance tests. As I said before, we encountered a bug in the Latigo library where after serialization the result to a binary file, the library could not reopen it, resulting in the backend failing to verify our result and returning an error. We debugged this issue and found a solution using the rescale method. Afterward, we refined our integration tests to check for this scenario as well. Soon, we realized that Latigo did not parallelize computations. By employing coroutines in Go, we managed the speed up execution by at least 3 times. In the final moments, we rewrote our code, reduced the number of multiplications, adjusted the parameters log Q and log N, and applied a parallelism in Go and managed to accelerate performance by an additional about 30%. However, we did not manage to upload these results due to a silly error, which we only fixed after the competition had ended. Thank you. That's all.
Okay, thanks. Does your team want to add anything? Valentina, Dmitry?
So yes, I have a question to all the Open FHE members that participated. Because we used Open FHE library to in Python, so we could not parallelize the neuron computations efficiently. Did somebody manage it in Python, or everybody just used C++?
Yeah, for me, I use C++.
Yeah.
But I didn't use any like parallel programming because I think the library already have.
Yes, they use
thread.
Yes, they use OpenMP, but in Latigo we could improve this speed really significantly.
I see.
Well, as far as I know, yes, nobody has tried to parallelize it in Python, or at least hasn't been asking questions. Well, Huey, will you continue with your story about CIFAR?
Yeah, okay. It's quite an interesting challenge. And at first, I thought it was kind of impossible because I had some experience with implementing the CNN in the encrypted domain. And to get a very high accuracy, like above 80%, we have to use a very deep CNN to do so. So it will lead to a very prolonged running time. But the task here is much more simpler. We just need to like overfit the data. So inside the whole data set. So I started with a very simple network structure that just has two fully connected layers. And that is one input layer and one output layer, which has 10 neurons. And after training it for a while, I can maybe 1 week, I can finally reach 100% accuracy on the whole Cypher-10 dataset. But I think anyone can, it is quite a very simple idea and anyone can try it. So I did try with something new, and finally I found a new network structure. It is the Kolmogorov-Agno network. So you may heard about it. It just recently introduced. So the idea of that network structure is instead of learning the layer weight, we try to learn the activation function instead. So it helps us to reduce the number of parameters significantly. And I did try this new network to solve the Cypher-10. And the result showing that with just one layer, we can reach 100% accuracy. So in the final submission, my model just have only one input layer and one activation layer only. The activation is a polynomial of degree 6, and it's there are maybe 4 depth of multiplications in total. And I try to use the lowest ring dimension to get the best result. Yeah.
Can I ask a question? Thank you for your explanation. I have a question for Osminoshka team. So it's two separate team, Valentina and you, right? Or how it works?
So not really. We are three friends. So one person does everything in Go. One person trains neural network. So we have exactly one neural network submitted. So what the only difference is the format. One is JSON, one is pickle file. Yeah.
I'm asking just because I see that your solution for OpenFHE takes around 2.5 seconds, but at the same time, for Latigo library, your solution provided by you, it's around 0.2.
Yeah.
So at least 10 times faster on Latigo.
Yeah. The reason is, so actually the code is also almost exactly the same, but in Go we used Go routines. Yeah. And we cannot just use parallel processing in Python. So if we wrote it in C++, I believe we could improve the speed almost like in Go, because we parallelized on the higher level, because we can parallelize on the low level, so like matrix multiplication, and we can parallelize on the higher level when we have multiple neurons, so we can start more threads to calculate neurons.
Yeah, thank you. Got it. Yeah, Alexandra, go.
Yeah, I just want to say that it was really engaging to watch your competition. Thank you for putting so much effort in it. Well, that's what makes us feel that we will have really the best solution, a better component as a result. If anyone has questions about CIFAR, now's the time to raise a hand.
I think we can go and discuss any questions, or if you have any questions related to current challenges or ongoing challenges or out of this, please feel free to ask. We will try to answer. Yeah, please go.
So I think I will name Hita. So because I cannot read this name, I don't know how to pronounce it.
Cool.
So I have the question about Go also. So have you used Go routines to improve your speed? No. So
no, actually, I'm just a newbie in Go language, so I normally use ChatGPT to convert the code from OpenFHE to Go to Latigo, and I will debug by myself afterward. So I just no experience in Go, and I never heard about the Go routine. So I do not use it in my code.
And does it work well?
Yeah, it's let me try to see how can. I think it can significantly reduce the running time if we use that parallel processing. Yeah.
You can try to upload. It will be interesting to see. Ritik, please go.
So I have a question for Hita for CIFAR 10. So you mentioned you reduced the ring size. So I'm guessing because your computation only had four levels, and let's say you wanted Q of, let's say, 60 bits or something like that. So you just reduce the size of the ring. That would give you that much multiplicative depth. Yeah. Am I understanding that correctly?
Yeah.
Okay, understood. Yeah, that was my only question.
Okay.
Yeah.
So we try to reduce the depth of the computation as much as possible. so that we can use the lowest ring dimension.
And what was your multiplication depth? It was 2, yes?
I thought it was 4 or 5. I don't quite remember.
So we had only 3.
5, 3. Okay.
So we also
I also apply some optimization. So for one neuron, I just try to learn from a part of the image. For example, for the first neuron, I just delete some connection from the last layer, so it can reduce the number of rotations that is needed in the computation.
Yeah, we used only 1 rotation, and you for the last. So we used only 1 rotation for the.
Just 1 rotation.
Yeah, for the to compute the last layer. So to make it 10. Oh no, was it 10? Yeah. But we had much more rotations because we have to sum everything, and so we reinvented dot product for this challenge because we couldn't use this eval sum operation.
Yeah, for computing the dot product, you need, I think, at least 10 rotations.
Yeah, something like this. So n-log 2 by
n-log 2. Yeah, correct.
If there aren't any questions on past challenges and ongoing challenges, I would like to ask all of the participants who we still have here with us, how do you choose your challenges? Like what you're interested in? How do you choose what to participate in? And how do you choose your approach? So raise a hand if you have something to say. Yes, Yanis?
Yeah, actually, we at our chair, we look at those problems that also occur in, like control theory. Also, we are looking a bit in machine learning, but more or less from this point of view from control theory. And actually, there this real problem. It even stems from from a different perspective. Not it is not only that we look from it from a machine learning perspective, but it present some other opportunities in control theory. So that's why we looked at the real challenge. And we will also be looking, for example, for us, really interesting would be like the max operation. We will be looking into that. That's more or less how I don't know about my team members, so I cannot speak for them, but that's more or less how I pick the different challenges that I would want to participate.
Well, we're definitely going to have some more ML challenges. Not sure how soon, but I saw Gurgen working on some of them. Let's move on to Asminotkas then.
So I also wanted to say, yeah, Valentina said that we participated in this CIFAR challenge because this is our main domain. We do a lot of ML stuff, and we wanted to try something new with the very new things for us, like homomorphic encryption, because this is like magic happens in real life. Also, the very interesting thing was to optimize the solution to make it as fast as it is possible. So we have even more ideas how we can improve the solution, but the problem is that we have limited time and we have our personal lives and work. So yeah, unfortunately, in this case, that is it. Thanks.
Thank you. I think we will publish new ML challenges in coming weeks, so it will be more tricky with some generalization. Yeah. Yeah, please.
So one point for this challenge, I believe, to make it more usable in real life. So to include it in maybe somewhere as a library or to reuse it. I believe to test the solution we should use. So because it is publicly available data set, we already know what is inside. But if we augment data in some way, for example, shift the 1 pixel left or right, or rotate it a little bit, or change the brightness level, then it is definitely, so our solution definitely doesn't work for this because we overfit for the data. And if we rephrase the task or change the task to implement, for example, ResNet 20 or something like this, and optimize it as hard as possible, then maybe it is more applicable to real life. So that's my
yeah, for sure, for sure. Thank you. And we just started with simplest one, but we will make it more complicated step by step. But for us at this stage was more important to engage people from machine learning without expertise in homomorphic encryption. I just wondering why you started with OpenFHE, because it looks like starting with Latigo with Go should be more simple.
In my opinion, it was simpler. So for me, because I have a Python experience and there is Python binding for this. That's why.
Okay, so we will provide for the next challenges. We got all your comments, so we will improve this part on our side and take it into account, everything. As I mentioned, I think we will publish new ML challenges in 2 weeks. It will be more complex. We'll see. We scheduled 1 hour for this call. We're now out of time, but if you want, we can. We're here. We can answer any questions. Jean-Philippe, I hope, can answer any questions related to Latigo, and yes, you can ask any questions about Latigo. Yeah, please.
Yeah, I just have one question about our previous winner of some challenge, Aikata. I'm curious why she she did not participate in the some recent challenges. Any reasons?
Yeah, so I'm a PhD student and this is not my domain of work.
Oh, okay.
I think I participated last time because there were Christmas
yes.
and I was bored. So now I think I did push some solution because I got some weekends free. But yeah, and I did not get time.
Yeah, the last time I was quite surprised about your performance.
Yeah,
So
but I also agree with Anna that for some time I was really like, Hita is not real. This is just somebody pushing me to work harder, but
yeah, I understand.
Oh yeah, that's true. We also thought that admin just trolling us. So whenever we have a better solution, he comes in and have a better timing.
Just try to improve.
So, any other questions?
I just want to add that if you have any questions or some thoughts or suggestions, you can always reach out to us via our Discord server or Telegram. For those who uses it, we have a small group. We're open to your feedback.
And also questions related to library, to Latigo library. Maybe Jean-Philippe can say what is the best way to ask the questions or communicate with community. For OpenFHE, they mostly use Discourse. Yeah.
And yeah, I want to ask when you plan to support the bootstrapping key in the FHERMA challenge? Because I think for some challenge, it is impossible if we don't have the bootstrapping key.
It's supported already, so it's
Oh.
supported.
I think in the
depends on the challenge.
script-
Sometimes, yep.
But I saw in the script to run the code, we don't have the bootstrapping key, just the rotation and the multiplication, as I remember.
Are you talking about black box challenges or white box?
It is white box.
In white box challenges, you can put all parameters you need for bootstrapping key in the config file, and bootstrapping supported.
Okay. Got it.
The same for Latigo library. We also support bootstrapping for everything. If you have any issue with it, just let us know. It depends. Sometimes it depends on the challenge. Some challenge, sometimes it's not allowed to use bootstrapping, but in most cases it's allowed, and we generate key.
Yeah, thank you.
So I wanted to ask, are you going to include some more schemes, or is the challenge going to be only for CKKs?
Oh, it's a great question. We already support BFE, BGV, and current a few challenges, as far as I know, published on the platform. You can choose any schemes you would like to use. So you can solve challenge with CKKS, or you can use BFE or BGV instead of it. It should be, let me check, but I remember that the last challenges we published, we opened opportunity to choose in config file which scheme you would like to use. In EVM track, we have the challenge shift left, which is based on BGV and BFV. And
so is it going to be the level schemes only, or are you going to include FHEW or DFG, for example?
Sorry, I didn't
Do you
get it.
have plans to include also FHEW kind of schemes also?
Which one? FHE?
FHEW or
You mean,
TFHE?
yeah. I got it. Do you mean TFHE scheme or FHEW? We will add it too. So it's just the question. We support all schemes. We just currently don't have challenges for TFHE or FHEW, but we will add it.
Okay.
Actually, if you have any ideas on your challenges, we have discussion on GitHub. Let me find it, which is called exactly ideas for new challenges. And you can post there your thoughts about challenges and schemes, languages, whatever you seem fit. Actually, we added Rust support via OpenFHE RS wrapper to the FHERMA, so all ongoing challenges should support Rust submissions too.
So I can again say thank you to all of you for participate. Thank you, Jean-Philippe, for support. Thank you, Chaim, for interesting challenge. So if there is anything to share, feel free to say it now. If not, I think we can finish this call. But we expect to have such kind of call around challenges, maybe with some period. So it should be a regular call, if it will be interesting, where we will be able to talk about challenges. So thank you.
Thank you.
Thank you.
Bye.
Thank you.
Bye.
Thank you.
Bye.
Have a nice day.
Bye-bye. Bye.
Thank you. Bye.
Bye.
Thank you, everyone.
Bye bye.